Okay, I just got the sign to go ahead and get started, so I'm going to do that. Yeah, appreciate the invite to come speak today. This is me, I'm TJ Alumbaugh. This is my talk. It's called Building TaxBrain Using Anaconda to Open Source Government Policy. So I'm going to talk a lot about open source today. I think for people who are generally in sort of a technology area, that is a very familiar topic, a very familiar concept, the methodology and philosophy of open source. And so a lot of this story is about taking those ideas that have been very transformative to the technology space and applying them in a totally different world, and that in this case is the world of government policy. And so that's pretty much the story of today. Before I do that though, there's a few other things that I want to talk about. I didn't really know what the audience level was, so some of this stuff I can go through kind of quickly, but I wanted to talk about who I am, the company I work for, and what Anaconda is, and all of that before we get into the main story. So this is what I want to accomplish today. Just tell you a little bit about Continuum, what we do. So the big reveal is that we like Python a lot, and we use it for data science. And so I'll talk a little bit about that. Actually, is there, how many people are familiar with Anaconda? Okay, cool. So that will go very quickly through those slides. And then I'll talk about this partnership that we had with an organization that has a mission to really transform the way that government policy is formed in our country. In particular, their starting place is in tax policy. So this might actually go pretty quickly, just to tell you a little bit about who we are. We are the company behind Anaconda, an open source analytics platform. It's powered by Python, which it sounds like many people here are familiar. It is the fastest growing data science language. So what we are known for is for open source software. We also have commercial software offerings. We do some training, and then solutions work as well. Our founders have a lot of deep domain knowledge, especially in the Python area. Our CEO is Travis Oliphant, who is the original author of NumPy and the first author of SciPy, and Peter Wang, who I'm sort of speaking in his stead today. We also have some Python core developers and a lot of smart people, so that's really good for us. Here's what we want to bring to the world is an environment, an analytics environment for what we would call maybe occasional programmers, analysts, engineers, people who have to write code for their job, but they're not programmers. And so what they want to do is interact with their data, make a picture, and go through the iterative process of analysis without pain. And we think Python is a great way to do that. Yeah, let me see if there's anything else I wanted to say on this slide. It's sort of we want all the things. And it's really about connecting people's curiosity and their experience with their data. And the marriage of those two things in the least amount of friction possible, and also in a way that allows people to collaborate. And then this is another big one that is kind of a theme of the talk, is that that you shouldn't be locked into how you can use your data. You want to connect your experience with your data in a way that is free. And if this is the right tool for the job, I want to be able to use that. If this is the other right tool for the job, I want to be able to use that. And so that's what we want to bring to the world. At the same time, people work inside of companies, and those companies have governance policies. They have authentication issues, security issues, and that kind of thing. And so we build things that solve those problems as well. But it's about, at the end of the day, the right environment depends on the person, it depends on the use case, and so all of these bullet points are valid use cases that people need to do they want to use the right tool for the right job. And so our argument is that the traditional business intelligence proprietary world is not sufficient for the kinds of problems that people are tackling today. And so we think that you need something that is open and then something that is fluid and flexible. And so we think that Python is the right answer for that. The world seems to be going that way and in agreement. These are some numbers about NumPy downloads or rather NumPy users. That number's probably a little bit conservative, but a lot of people like to use NumPy. It sounds like, so it's so many hands in the air, a lot of people know about it. It's a way of doing numerical computing inside of Python. The other thing that is nice about Python is that we have over here on the right-hand side what we would call the occasional programmer, the domain expert who just needs to write some code to get their job done, all the way from the application developer, this is the software engineer, and even the DevOps person. That Python seems to be very popular with all three of those groups. And also I think this slide reflects that a lot of times there's a continuum there in terms of what people do on their day-to-day basis. These are another great things about Python. I think I'll skip that just for time. So what's Anaconda? We built this, enhanced Python, enable data scientists. Raw Python has some bumps. If you go to python.org and start downloading and try and do things. So Anaconda aims to smooth out those bumps. Easy setup for non-software developers. Handling the package dependency problem, cross-platform kinds of issues. So the Anaconda Python distribution, basically this is what you get. It's open source software. It comes with a curated set of very popular Python packages for common data science kinds of needs. Many of those packages are compiled for your platform. You choose to download Windows, Linux, Mac. We also now ship with R packages as well. And this is the foundation of our enterprise products. We also have an Anaconda Enterprise where we do on-premise solution for companies that want to put Anaconda inside their organization. So that's who we are. That's a little bit of what we do. So this project was a partnership between us at Continuum and an organization that I mentioned that wants to change the way that tax policy is developed in our country. And so this project that we call TaxBrain is about making a model that has these characteristics, that high performance, accessible, modular, and easily deployed. So our partner in this organization and the sponsor for the work is the Open Source Policy Center. They are a group with the goal of, basically they want to use open source methods to build economic models that influence the way that policy is created in the United States. So to give a little background on that, what is the current state of how that stuff works? Well, what happens is, whether people know this or not, tax policy, healthcare policy, Social Security policy, what's going to happen in the future? How much money are we going to spend in Social Security? How much money are we going to spend in Medicare and all that kind of stuff? Those questions are answered today with computational models. The software for those models is proprietary, and oftentimes even the Congress people who are voting to enact policies that were the results of which policies are predicted by software models, they don't get to see the code. Their staff doesn't get to see the code. And the issue with that, there are many issues with that, but one of them is that the implicit assumptions of that model are not available for everyone to see. And that's a big problem. And so one of those things is you don't get to catch people's errors. But the other one is, it inhibits external review, stifles innovation, and it limits the debate because you don't get to say, well, why did you choose this? Why did you use this? And all of these people that I've been working with over the last year or so, they want to see the code. They're very interested in knowing your modeling assumptions. So the purpose of the OSPC as an organization exists to change that. So the way they're going to change that, the way we have been attempting to change that, is to simply build a model from scratch that is open source. And so the beginning of that model is a Python package called TaxCalc, or we just call it the tax calculator. It's an implementation of, actually, there's a little bit more here, not that if you're an expert in this area, it's not just federal income tax code, but it's also individual income and payroll tax now. So money that you never see but your employer has to pay. It answers these kinds of questions. What is the effect, if we raise or lower the capital gains tax, or if we bump up, this tax bracket, bump down, how much more revenue will the government get over? Typically what they care about is a model that gives you a 10-year budget time frame, 10 budget years.
How about all these deductions?
Yes, yes. And actually I have a small demo where so to really implement, that's one bullet point on a slide, but it's a lot of boxes, a lot of data, a lot of fields. And so this is, ultimately that is the complexity of the problem, is all the different kinds of deductions and credits and exemptions and all the limits and brackets and everything. But the math is actually very simple. All that you do is you take a whole bunch of tax returns that are a representative sample of all of the tax returns. There are about 120 million every year. Put in you just have a parameter for every single part of the federal income tax code, and then you calculate each individual record's tax burden for that, for that entire year. You use a model to step those returns forward in time, assuming maybe people gain certain raises or something like that, and then do it again, and then do it for 10 years and add it all up. So it's really just arithmetic at the end of the day. And when you want to do a policy reform to say what's the change, what would happen, what if we change the top tax bracket, increase it or decrease it or whatever, then it's just two different kinds of arithmetic and then just you find the delta. So step one in this process, if you want to make one of these models, is you need to write the code. Step two, I would argue that you want to make it fast. And so we use Alumbaugh to do that. So how many people have heard of Alumbaugh? Oh, okay, so quite a few. It's a just-in-time compiler for Python that uses the LLVM compiler infrastructure. I think the issue is that naive people like writing Python code because it looks very nice. Naive Python code is very slow. You can write fast Python code. It tends to call out to various libraries that have compiled routines inside of them. So you can have nice looking Python code. You can also have fast Python code, but it's very difficult to have fast, nice looking Python code. And so Alumbaugh is a solution to that problem. And so this is what I say, is that Alumbaugh helps humans read fast Python code. And so if you get really into the guts of NumPy, if you're a NumPy user, you oftentimes have to do little cartwheels sort of to actually get the result of what you want. And Alumbaugh helps you avoid that, and it uses it does this through the compilation mechanism, or the JITting mechanism that we use when we say for a just-in-time compiler, is enabled through function decorators. And so by decorating your Python function sometimes at import time, module import time, or sometimes at call time, we will invoke the compiler to produce machine-level code, machine-native code for your function. You've written the code, you've made it fast, now you want to make it accessible. So if this is still working, if I'm connected to the internet, I wanted to do just a really brief demo. We'll see if this works. So this is TaxBrain. It's at ospc.org/TaxBrain. And here we basically have there's a lot of instructions on how to use it, but essentially this is the payroll tax section. But every single type of, it's tax time. If you haven't done your taxes yet, the government likes a lot of these different boxes, and every single one of these boxes that's from your tax return, including all the different kinds of credits. And so here we have all the different kinds of taxes and everything. So for example, if you wanted to raise the personal income tax rate on the top brackets, we're going to tax the wealthiest people, maybe in the top 2 brackets, and change their tax amount by a certain amount. And you need to have a large browser window to make this work. Let's see if I can actually get this to work. Oh, that's hilarious. Well, that's not going to work
And
today.
in the bars, there'll be a zoom.
What's that?
In the little red bars, the upper
There we go. So we'll need to file a bug on that. But so basically, you start this calculation off, and it goes and does this calculation of basically what I was showing, applying your tax logic, your new reform. Basically, this is the way the new tax law is going to be for 10 years. It does the same thing with the standard, status quo. What if we change nothing? And then it will report both of those results to you over 10 different budget years, grouped by various different kinds of things. So we group it by deciles of income or income brackets and that kind of thing. So here, this is just kind of like, so we basically increased the tax, increased how much revenue the government's going to bring in. So our calculator says that if you change those tax brackets the way that I suggested, you're going to bring in this much more revenue in billions of dollars over the next 10 years. And then you can break that down by all different kinds of ways. You can get the differences across all the different tax brackets and all these kinds of things that the policy people care a lot about. So that is what it does. The general idea is that, I'm going to try and go real fast here. The general idea is that you don't have to be a programmer now to be able to try out these reforms. And so you can be just everyday citizen. You don't have to sign anything to get access to the code. You just go and use it. You can also get the code itself on GitHub. So we use Conda, which sounds like a lot of people are familiar with here, and deploy the code on AWS. So we actually, not only do we speed it up with Numba, but we also split up. We actually do each budget year on a separate machine so that we can split up the work. And then it's not a totally embarrassingly parallel job, but you get a good speed up by doing it that way. Then we serve all out of the work onto the AWS nodes, and then give it back and bring it to you on that table that we show. So I'm going to skip all that. But basically, I want to say that this is the kind of thing if you want your model to be very impactful, whether it's inside a business or in public policy or something, it needs to be fast, accessible, modular, and easily deployable. Those ones are particularly important because now we're taking this tax calculator and shoving it into and making it, not only does it work inside this web application, but also other economic models. And so there's kind of a viral effect here that as a model becomes more and more accessible, other people want to build models that leverage that model and that kind of thing. And open source solutions, empower more people. More people are going to have access to this power to basically say what would happen if I changed the policy in this way. It's more transparent. Every single answer that we get, you can look exactly at the code that produces it. It's more flexible. You can take these results and do a lot of different things with them, and take the code and do a lot of different things with them. And then, as I mentioned, the extensibility of plugging in your own component to the tax calculator for how we do population growth and so forth, and then also taking the model and sticking it in and having other models leverage your model. I guess I did pretty good on time. I got a few minutes left for questions, but this is just the end slide. Please go to our website and download Anaconda if you haven't or would like to try it. You can find me on Twitter. And we also, so this is one of our really great partnerships that ended up with a really great story, but we also do other types of customer solutions. Sometimes people want to shout aloud about cool things we do with them. Sometimes they keep it inside the walls of their company, but would be interested in talking about that. And then we also do offer training in Python. So that's my talk. If anyone has any questions or? Yeah. Oh.
Earlier, I think you had a slide talked about a data warehouse through Azure. Is that for Python?
Yes.
Okay, and my understanding, that's Microsoft?
Yes, yeah.
And yet you talked about AWS with this
Yeah.
particular model. Is that a big hang-up? In other words, are you wedded to, in the case of the Python, to the Azure, to Microsoft? Some people have a problem. Or is it pretty portable?
Well, let's see. So this solution was, I mean, we do have, for this solution, we do have AWS specific code for, for example, when we want to launch new nodes, that's, that kind of thing. You have to, at some level, even if you script it out, you basically have to say, okay, use the EC2 infrastructure to launch a new node, right?
So Chef, or they won't handle that?
What's that?
Chef, I would have thought there's
Yeah.
an API.
Yeah, we use Fabric with Salt, and but even when you define a salt state, you sort of have to say. But I mean, in terms of Python code itself, I mean, this is a new thing that the Azure ML Workbench now launches with Anaconda, and so if you like, they have a new feature going up right now where you just click a button and launch a Jupyter Notebook. And the Python that runs that is Anaconda. And that was just like last week.
So you can do anything making it independent of the cloud?
What's that?
Are you going to do anything to make it independent of the cloud?
Make what independent of the cloud?
The Python environment, of which you've already said I'm going to make the Python environment better by doing Anaconda.
Yeah, so you can download Anaconda on your machine.
And then Python will run on Lumix or something.
Say again.
On Lumix or whatever IBM's calling their lowest level.
Ah.
I just picked another guy.
Well, I mean, we have installers for Linux and OS 10 and Windows, and so I don't know. Maybe we can talk
So
offline.
it's only a deployment issue. It's not the warehouse's APIs.
Yeah.
It's like,
Yeah. Maybe we'll talk offline
well, I thought
or.
this group would be interested in what goes wrong when I pull on Anaconda.
Well, no, I don't think I understand. I think is what the issue. I'm not sure I understand what your question is. So, yeah, I think that's the heart of it. But yeah.
Does TaxBrain attempt to expose and let you tune things like around incentives, like whether people will start new businesses under different formations? Like a lot of tax debates are more about how people will respond.
I promise he's not a plant. I promise. So what you're talking about is dynamic simulation, or this is in this world is called static scoring versus dynamic scoring. So for a given, this was a static score, very easy math that I already told you how it works. We have a number of dynamic scoring kinds of things. So the idea would be, how are people going to respond if you lower the tax rates? Well, it seems like that will spur economic activity. Well, to what degree? Well, that's a parameter of your model. And so we have two different kinds there. Actually, there's a third one that was under construction. It's almost ready to go. But that's the way that it would do. It basically, tell me what you want, how you want to change policy. Then I do the calculation. And then for these various kinds of models of increasing sophistication, that typically starts to get more into domain expert land. Like the first part, a curious person could be like, oh, what if we just change the tax policy this way? As you start to drift more into that, it gets a little bit like intense for the layperson. But we do have those.
Yeah, kind of building off of that, is that where you see more of the debate going on with the policymakers, the assumptions that go into the dynamic scoring?
That's what our sponsor is that's why there's all this verbiage here, and this is our main guy, Matt Jensen, who is the founder and managing director of OSPC. He is very careful about some of the language that we use here, because that is the big debate is in the dynamic scoring. Number one, it seems clear that some kind of dynamic scoring is appropriate for 10-year budget window analysis of like what's going to happen when we turn these knobs on various kinds of our economic policy. But how much should you use a dynamic score? What type of model should you use? And pretty soon we're going to have 3 different models available, and probably 4 by the end of the year. And so which one should you use, and what are the parameters, and da-da-da-da-da. But right now, all of that stuff is done in a very proprietary way that people don't get access to the code. So, yeah.
You mentioned about something about some implicit assumptions that are made. Even this one has some assumptions. Where do you get that data from? Is it something that's based on like open public knowledge? Or?
Yeah, some of them are. So we have about 3 or 4 different repos on GitHub. So on GitHub, our organization is called Open Source Policy Center, and some of those repos, for example, one modeling assumption is how are wages going to increase over time, and the Congressional Budget Office has some answer to that question, but in particular, that's one that they absolutely do not tell people what they think is going to happen over the next 10 years. And so in our model, basically there's some linear programming stuff that happens in a separate repo that offline calculates those parameter values, and then we basically say we're importing these values based on this repo, and that's where the code is, and you can run it. So that is not tunable on TaxBrain. It's tunable you'd have to go download the package and do it. So we kind of have a couple of knobs on the web app that aren't tunable via the web app. But yeah. Okay, thank you.